Hello everyone. In this lesson we are going to focus on the second part of SAT Math hard questions of numbers and operations. Let's start with the first question. Suppose that m and n are positive integers such that m times n is greater than 15. If f15mn is a perfect square, what is the least possible value of mn? M times n is greater than 15 and 15 mn is a perfect square. First, note that 15 mn is equal to 3 times 5 times m times n. We need square root 3 times 5 times mn to be an integer. Okay? We could have, for example, m is equal to 3 and n is equal to 5. Since square root 3 times 5 times 3 times 5 for this case is equal to 3 square times 5 square, which is equal to 15. But the problem requires that m greater than 15. Indeed, this is a hard problem for a reason after all. Now, if m is equal to 3 times 2 and n is equal to 5 times 2, then 15 mn will be equal to 3 times 5, 3 times 5 times 3 times 2 and times 5 times 2. This is equal to 3 square times 5 square times 2 square. In that way, 15 mn will be equal to root 3 square times 5 square times 2 square. This is equal to 30. This is an integer, making the least possible value of mn equal to 6 times 10, which is equal to 60. That's the answer. This is the least possible value of mn. I hope it's clear. Please let's go to the next question. Question 2. M is a set of 6 consecutive even integers. When the least 3 integers of set M are summed, the result is x. When the greatest 3 integers of set M are summed, the result is y. Which of the following is true? 6 consecutive even integers. X and Y. This is a good opportunity to plug in real numbers. For example, suppose set M consists of the integers. Let's say M is equal to 2, 4, 6, 8, 10, and 12. The sum of the least 3 is 12. So least 3, that means X is equal to 2 plus 4 plus 6, which is equal to 12. And the sum of the greatest 3 is 30. Then Y is equal to 8 plus 10 plus 12, which is equal to 30. If you combine these two, then let's say, since Y is 30, 30 is equal to X is 12, 12 plus, what's the number? It's 18. Therefore, answer B is correct. Okay? Now let's go to the next question. Question 3. A three-digit number XYZ is formed of three different non-zero digits X, Y, and Z. A new number is formed by rearranging the same three digits. What is the greatest possible difference between the two numbers? First, note that to get the greatest difference, we want to subtract a small number from a large one. So we will need the digit 9 and the digit 1. Let's assume digit 1 in order to make a number in the hundreds and a number in the 900s. So the large number will look like 9 and 1. And the small number will look like 1 and 9, where n is a digit from 2 to 8. For example, let's say the number is 9, 2, 1, and the small number is 1, 2, 9. We subtract 129 from 921, and 129. It's 2, and it's 9. It is 7. 792. Let's give another example. Let's assume that the number is 9, 4, 1, and 1, 4, 9. Let's subtract 149 from 941, then 941, 149, subtract this 2, this is 9, and this is 792. You will find that no matter what you make n here, the difference is always 792. That's the answer. I hope it's clear. Now let's go to the next question. Question 4. An integer is subtracted from its square. The result could be which of the following? A. A negative integer. B. An odd integer. C. The product of two consecutive even integers. D. The product of two consecutive odd integers. E. The product of two consecutive integers. Suppose that the integer is n. The result of subtracting n from its square is n squared minus n, which is equal to, let's factor out n minus 1, which is the product of two consecutive integers, isn't it? For example, let's say n is equal to 8, then n times n minus 1 is equal to 8 times 8 minus 1 is equal to 8 times 7. Two consecutive integers. So, answer E is correct. I hope it's clear. Please like and subscribe to my channel. Thank you very much.